about yesterday's class test. The plan is to get that marked as soon as we can, so hopefully the results will be out by the end of the week. Probably in some kind of format up on Blackboard. And then Peter will be having a look at the solutions for the class test next Monday, which is when I think you have to handle your first assessment. Okay, today's session is the second in this small block of covering this thing called run-off triangles. Just to remind you, on Friday we looked at a very basic chain ladder method, which was a method for projecting total claim payments or going into the future. Today we're going to have a look at three kind of slight variations on that same thing. The first one is to see how that basic method is adjusted to take into account inflation. And that's both accounting for inflation on the historical data, but also accounting for inflation going into the future. The second variation is slightly different, but uses the similar ideas, which is called the average cost per claim method. And what that does is, in addition to the cumulative claim payments, which the basic chain ladder method worked on, it takes into account the numbers of claims as well. So I'll talk very briefly about that method. And then finally we'll come on to a third variation called the Born-Quetta-Ferguson method, which again takes into account some other information that you will have, which is the premium income that an insurance company will have corresponding to the different origin years. Okay, again, similar to the last lecture, there are thousands of numbers here. Okay. You can't expect to get your head around every single number during the lecture. So just try and take away the basic ideas. You can always check my arithmetic outside of the lecture. Okay? All right. So the idea here is that, as I say, we need to take into account inflation that has happened in the past. And in that sense, what we want to do is using the basic chain ladder method, you'll remember that we calculated these things called development factors, which tell us how claim payments will emerge in the future over what we call development years. So we want to recalculate those factors, taking into account past inflation. It's fairly straightforward. Basically what you have to do is bring everything up to current prices, and then you recalculate these development factors. So that's one thing. The second thing that we need to do is to take account of inflation that is going to happen in the future. All right. Now again, just going back to the basic idea from Friday, you remember that we started off with a table in which the numbers represented cumulative claim payments, and they were cumulative claim payments over a number of years. Now, to kind of factor in inflation, to take out inflation, what we first have to do is to calculate the incremental claim payments. Okay, we'll see why we have to do that when we look at an example. But basically, it's very simple to calculate those from our basic table that we start with, which is take differences along the rows to obtain these incremental claim payments. So that's the first step. Okay, we've got a table of cumulative totals. First step, calculate incremental claim payments. Then what you do is you adjust for the past inflation on your historical data. You recalculate then the development factors We then use the basic chain ladder method that we had last Friday to project into the future. And then the final step is adjusting for future inflation. So it's just going through a number of steps. It's once you've got your head around what's going on, it's reasonably straightforward. Okay, so we'll just take you back. So this is exactly the same example that we had last Friday. Okay, so just to remind you, the rows correspond to different accident or origin years where claims, incidents took place. And then across the columns of the table we have different development years. So again, just to remind you, we take origin year 2008 as an example. Some claims are immediately paid for accidents that happened in that year. This is this first cell here, £786,000 in claim payments made almost immediately. And then by the end of development year 1, so this is by the end of 2009, okay, some further payments are made, so the cumulative total at the end of 2009 for accidents that happened back in 2008 are about 1.41 million, and so on and so on. So finally, by the end of development year 4, so this is by the end of 2012, well, the assumption is all of the claims have been paid off for accidents that happened in 2008. So the assumption is that everything is paid off within 4 years, and this is the total amount of claims that have been paid out by the end of 2012 for accidents that happened back in 2008. And then so on down the table. So basically this bottom right-hand triangle is the future, and we're trying to predict numbers for each of the cells of that lower triangle. Okay, so that's just a quick recap on the basic structure of the information that we have. So to adjust for inflation, so the idea here is that, I mean, we'll take this figure here, at the bottom, £1.182 million has been paid in claims in 2012, okay, for accidents that happened in 2012. But back here, £786,000 has been paid back in 2008, corresponding to accidents that happened in 2008. So obviously between 2008 and 2012, presumably inflation has taken place. So if we want to put all these numbers on the same basis, what we need to do is adjust this figure up here, 786, according to inflation over the years 2008 to 2012. So the first step is to create a table of incremental payments. Alright, so that's very easy. So all we do is take differences along the row. So for example, starting at the top, the incremental amount paid in 2009 corresponding to accidents that happened in 2008 is simply 1410 minus 786. Alright, and then carrying on, by in 2010, the amount paid in 2010 corresponding to accidents in 2008 will be 2216 minus this cumulative total of 1410, whatever that is, 806. So you just work your way along each row of the table to get these incremental payments. Okay, everyone happy? So we produce, by doing that differencing along the rows, this table of incremental payments. Right, now let's have a think. Well, just to note that all the numbers along this main diagonal here, this final diagonal, are actually payments made in 2012. Okay, this is a payment made in 2012 corresponding to accidents in 2008. Okay, so those numbers there, they're actually at today's prices. When I say today, I'm pretending that I'm sitting at the end of 2012. All right, so those numbers don't need to be adjusted for inflation. But if you take all the numbers on the previous diagonal here, 224, 940, 819, 1220, they are all payments made in 2011. Right, so to bring them up to today's prices, we need to multiply those numbers by the inflation between 2011 and 2012. Okay, well, this bottom box here, these are just some kind of arbitrary numbers that I'm using for this example, which denote the inflation rates at during or across different bits. So, for example, this is the inflation rate at mid-2012. So prices have increased by 5.4% from the middle of 2011 to the middle of 2012. So what you need to do, for example, is to multiply this number here, this incremental payment of 1220, which is paid in 2011, multiply by 5.4% to get to the value at 2012 prices. Alright, and you would need to do that same kind of multiplication for all the numbers sitting along this diagonal here. Look at these numbers here, 806, 671, 995, those are payments made in 2010. Alright, so to get them up to today's prices, we first need to multiply by 7.3%, which is the inflation rate for 2010-11, and also then multiply by 5.4% to get them to today's prices. Okay, and so on. So the final number you need to adjust is 786. That's a value of 2008 prices. So we have to multiply that number by the product of these factors, 5.1, 6.4, 7.3, 5.4. Okay. So you adjust all of those incremental payments to get them all at 2012 prices. And that summarises what I've been talking about. That is how you get the inflation adjusted incremental payments. Okay, so these boxes are just giving you some of the examples of the precise calculations to get to these adjusted, inflation adjusted incremental figures. So you can check those in your own time and point out all of the mistakes that I've made. Okay. That's fine. Next thing, we need to just go back and return this table into the cumulative totals format, and then just use the basic chain-letter method that we had on Friday to calculate development factors. Alright, so we adjust this back to a table of cumulative totals. Alright, so again, it's just working with these increments and then the cumulative total for development year 1 corresponding to 2008, 994 plus 751. This one here, we'd just be adding up all of the numbers on that first row to give the cumulative total payments for development year 4 corresponding to accidents in 2008. So we get back to a table of cumulative payments where now these cumulative totals have all been adjusted for past inflation. Okay, now we apply exactly the method that we had on Friday, where we would calculate these development factors. Alright. So just to remind you how you do this, the year 0 to year 1 development factor, just go back. What you do, so this is calculating the development, this is calculating the factor, showing you how claims emerge over the years. The development year factor for 0 to 1, what you do is combine all of this historical information that you have. Alright, so we've got information for accidents happening in 2009 to 2011. So what you do is pool the information, so you add together the numbers in this column and then divide by the sum of the numbers in the first column, and you get your development year, year 0 to 1 development ratio. 1.7334. Okay, similarly for the development factor for year 1 to 2. Alright, we're pooling information across 2008 to 2010. 2656 plus 2837 plus 3055 divided by the sum of those three numbers will give you the year 1 to 2 development ratio, and so on. Okay, then using the standard method for the basic chain ladder method, you would apply these factors, okay, to run off this triangle to basically predict the numbers for the red cells. Okay, just as we did on Friday. So for example, just to remind you, if we take this cumulative total here, 3118, to predict the total claims payments by the end of development year 4, we take this number here, 3118, and you multiply by the development year factor for year 3 to 4. Alright, which is this number down here. So multiplying by 1.0273 will give you the predicted claims payments by the end of development year 4 for accidents that happened in 2009. And so on. Okay, so the red numbers are now predicted cumulative totals into the future for the accidents happening in the different accident or origin years. So we might look again at the final column of red numbers here and maybe think that if we add those up, then that gives me the total claims payments made for accidents happening between 2009 and 2012. Well, that's not quite true because it doesn't take into account the fact that inflation is going to happen into the future. Okay, so this number here, 3204, is predicted cumulative payments that you would have made by the end of 2013 for accidents happening back in 2009. Well, we're still at the end of 2012. There will be some inflation, so we need to adjust part of this figure for future inflation. Obviously, this has already been paid, 3118. So the difference in these two numbers, the increment, the bit that we will pay in 2013, we need to adjust for the inflation that's going to happen between 2012 and 13. So, okay, keeping your head straight on this, what you have to do again is work out some incremental payments for this bottom, for the lower triangle. So you need to work out the incremental payments for each year into the future, corresponding to each of the origin years, and then take those incremental payments and adjust for inflation that will happen in the future. Right, now, of course, you don't know what inflation will be, but we can come up with some kind of estimate from the economists, the finance guys. They'll tell us what's a reasonable number to use. Okay, so next step, as I say, calculate incremental payments corresponding to that over time. All right, just taking some different single rows, and we get this set of red numbers. And now you adjust these red numbers by future inflation. So just to make things simple in this example, the assumption is that we'll have inflation in the future of 5% per annum. Okay. So what that means is, if I go back to this red number up here, 85,000 is the amount of money we're expecting to pay in 2013, right, corresponding to accidents that happened in 2009. So I need to multiply that by 1.05 to adjust upwards for inflation. Take another example here, right, 94. This is the amount of money, 94k, that we are expecting to pay in, when is that? 2016. Right, this is development year 4. Alright, so you need to adjust this number, 94, by inflation that happens in 2013 and 2014 and 15 and 16. So you end up needing to multiply this 94,000 by 1.05 to the power 4. Okay, and similar to 295, you'd be multiplying by 1.05 to the power 3. And so on. So all of these, well, again, if you look at down the diagonals, the 85, 287, 1174, 867, they are all being paid in 2013, so you'd adjust those by 1.05. 91, 318, 1090, adjust by 1.05 squared. 101, 295, adjust by 1.05 cubed. And then the final number, adjust by 1.05 to the power 4. So, we get these red numbers. So now the red numbers here in the bottom triangle have been adjusted by future inflation. Okay? Again, they are incremental payments. And basically that's it. So it's a bit of a kind of fiddle adjusting for past inflation and also future inflation. But I think once you've seen one or two of these examples, it's relatively simple to perform. Okay, so again, the bottom box there is just giving you some precise details of exactly what I've been explaining. So those are the incremental payments going into the future. So if you like, you can work out, you can work out cumulative payments. But essentially, if you add up those red numbers, that is what you are going to have to pay in the future, corresponding to the accidents that happened in 2009, 10, 11 and 12. Okay. So the reserves that we need to cover those claims sum up those red numbers. Okay, and we get 4761. That's now, again, in practice, of course, you might not set it aside exactly that amount for all kinds of reasons, but one thing it doesn't take into account, for example, is that the insurance company isn't going to just set aside 4.761 million and stick it under the bed. It will invest that money and it will get some kind of return on that investment. So, in principle, you probably need to set aside a little bit less than that because it's going to get investment returns on that money. So that's one thing that's not taken into account. Okay, what assumptions have been made? Well, pretty much the same assumption that we made on Friday once you've accounted for inflation. So the big assumption is that really these development ratios that we calculate based on historic data apply for each of the years. Okay. Again, as I say, once inflation has been adjusted for. Okay, so that covers the basic method of adjusting for inflation in this process. The second method is something slightly different, which takes into account the actual number of claims as well as the claim amounts. So the basic method only takes into account claim amounts. This idea works on an average cost per claim, and so takes into account the actual claim numbers. One little idea here is of course, this can be used if you know that you have some claims, all right, but you don't yet know what the claim amounts for those claims are going to be. So you can use this by, for example, as it says here, if you've got 5 claims, you know you're going to get some claims, 5 claims, you don't know what the payment amounts are, you can perhaps, from the historical data, project some kind of average amount that the claim would be for those 5 claims. So this is sometimes a useful method to take into account those particular situations. Okay, the basic method works as follows. What you do is you do 2 sets of projections. Okay, first of all, you project the average claim amount. Okay, from your historical data, you have claim totals and you have numbers of claims. From the historical data, you can work out the average amount of each claim for the historical data, and then you can project that average into the future in pretty much the same way as we've been using so far, by calculating development factors and then making a projection. You also project the number of claims into the future. So you've got the historic data on the number of claims. Again, project those into the future to get some estimated total number of claims. So then you can combine the 2 sets of projections. You've got some average payments per claim in the future, projected into the future. You've got some total numbers of claims projected into the future. Multiply one by the other will give you total payment claims. Okay? So that's the basic idea. There's nothing really new in terms of procedure here. And again, there are little tweaks. You can adjust the claims payments for inflation. Little warning there, you don't adjust the claims numbers for inflation. We don't have time to cover a specific example here, but there is one coming up which is on problem sheet number 5, where you get to try this out. Okay. So it's just taking into account a bit more information in your projections. Okay, well finally, a third method is something called the Vaughan-Quetta-Ferguson method, which again is taking into account a little bit more information into your projection method. So first of all, just start off by defining something called a loss ratio, which is essentially what's called the ultimate incurred claim. So this is the total incurred claims or total payments that you made for accidents corresponding to a particular year, divided by the premium income that you get corresponding to that same origin year. Okay? So that's what's known as the loss ratio. So loss here means that the claims, the money that you're paying out. So typically this can be a fairly steady number across different years. And the idea is that if you wanted to predict what total payments or total loss might be in the future, what you could do is use a kind of historical loss ratio and apply that to the total premiums in the current year to get an initial estimate of the what's called referred to as the ultimate claims. Now, as I say, often this kind of loss ratio is fairly stable across years, and part of the reason is, of course, insurance companies will set premiums that kind of take into account their expected payments. However, in some years it may be the case that you get odd things happening. So, for example, last winter was particularly severe. All of January and February, you may recall, it rained rather heavily. So I suspect insurance payouts on buildings insurance or contents insurance were probably quite high. So you may get odd events, extreme events, where in that year maybe the historical loss ratio is not a particularly sensible thing to use for that particular year. Anyway, let's set that aside for a minute, and we'll assume for the purposes of explaining this method that the historical loss ratio is something that we might use to at least initially predict total loss or total claim payments. So basically the idea is to say you initially use that historical loss ratio, apply it to the current premiums that you've collected for a particular year. That will give you an initial estimate of total claims that you may have to pay. And then what you do is you factor in these development ratios because you know for your current data how claims have developed up to a certain extent. So it's almost a combination of the original simple chain ladder method for predicting into the future, and also this idea of using the historical loss ratio to get an initial estimate. And as we'll see at the end, it's basically the Born-Quetta-Ferguson prediction or estimate is actually a weighted combination of these two values. Okay, the prediction that you would get using the simple chain ladder method, and the prediction that you would get using this very simple estimate using the historical loss ratio. Okay, so to see how this works with numbers, again we'll use exactly the same example that we've been working through since Friday, and we've just added some extra information about the premiums that have been collected corresponding to these origin years 2008 through to 2012. All right, so this is actually known. This is the money that we've got in through premiums. Again, these numbers in the top triangle, remember, this is historical data. This is stuff that we know. Bit in the lower triangle, we don't know. So, first step, historical loss ratio, what is it? Well, what I've done here is just to take the data for origin year 2008, which is fully developed, fully known, fully paid off. If I calculate or estimate a kind of loss ratio just based on that data, then what I'd be doing is taking the total amount that I've paid out for those accidents, so that's 2.519 million, dividing it by the premium that I've received corresponding to that year, which is 2.908 million. Okay, so that ratio is 0.866. Alright, so what I'm going to do for future years, accidents in future years that have not fully developed, I'm going to use this loss ratio, I'm going to call it 86%, to give me an initial guess at what my total loss or total claims payments will be. Alright, so the idea is to get that initial guess, I'm just going to take this loss ratio, assume this holds for accidents happening in 2009, 10, 11, 12, multiply this loss ratio by the premiums collected in those years to give me an initial estimate of total loss. So for example, for accidents happening in 2009, I will estimate that the total payments, total cumulative payments made, the total loss will be 86% of 3364. Okay. For 2010, again, assuming the same loss ratio, 86%, multiply 86% by premiums collected in 2010, which is 380. So I'm just multiplying the 86% by the premiums to give me an initial estimate of the total loss for each of those years. Okay. Now what I do is use the development factors that I've calculated using the basic chain ladder method. Right, so going back to Friday or earlier today, development factors calculated, pooling the data, combining data over the years that you've got the data for. Calculate those development factors. Okay, and so this is just the calculations, first of all, of our initial estimate of the total loss, the ultimate loss, historical loss ratio multiplied by premiums gives me this initial savings. Okay. Next step, calculate the development factors. All right, so again, we've done this already. We did this on Friday. Development factors, and here I'm just setting aside inflation. I'm not bringing that in to confuse things here. In practice, you probably would do. So these were the development factors that we calculated back on Friday. So for example, development year factor for year 0 to year 1, 1.775 was year 0 to 1, pooling these four numbers, add those up, divide by the sum of these four numbers here. So this set of development factors we've seen before. From those development factors, you can calculate things called projection ratios. Like so. So the projection ratio basically tells you how the cumulative total payment will develop from the year of the last claim right to the end. So if I take an example, year 0 to 4, you multiply all of these separate development factors that we had on the previous slide together. Okay, so just go back, so we end up with a factor of 3.2209. Right, that, if I just go back to our original data, right, what that does is it tells me how this would be projected forward to the end of this year. So if I was using the simple chain ladder method, basically that is how I would get an estimate of the total claims, total cumulative claims paid by the end of 2016 correspond to accidents in 2012. It's just a product of those separate development ratios, which is this number 3.2209. Okay. Similarly, year 1 to 4 would be the product of these three individual development ratios, and that would tell me how I would predict the number in this cell from the basic chain ladder method. I'd be taking 2142 and multiplying by the product of the development factors, year 1 to 2, 2 to 3, and 3 to 4, which is equal to this number here, 1.8121. Now, the clever thing is that if you invert, for example, well, any of these numbers, if you invert the first number, 1 over 3.22, tells you the proportion of the estimated total claims that you have paid at that time. So, idea of that. So let's go back and look at an example again. 1 divided by that factor 3.22 tells you what this number here is, 1182, as a proportion of the total predicted cumulative payment by the end of development year 4. So it's saying 1 over 3.22, which is, whatever that is, about 30%. 30% of the claims have been developed by the end of year 0, meaning that another 70% of the claims have yet to be developed. Right, so that's the key. You invert these projection ratios to tell you how much or what proportion of the claims you've already seen, and therefore what proportion of the claims are left to emerge. Alright, so you take 1 over f, 1 over this projection ratio, that gives you the proportion that has emerged. 1 minus 1 divided by f gives you the proportion left to emerge. Okay, so here's an example that corresponds to that bottom row of the table. My projection ratio 3.22. I invert to get 0.31, so it was 31% of claims have already emerged, and therefore 1 minus 1 over f, i.e. about 69% of the claims have yet to emerge. And then what you do is you apply this percentage that is left to emerge to your initial prediction of the total claims payments made back here, which used the historical loss ratio and the premiums. Alright, so for the year 2012, our initial estimate based on the historical loss ratio and the premium was 3.821 million. So what I'm saying now is I've worked out from the development factors that I had 69% of that amount left to emerge. Okay, so my estimate will be that I've got 69% of 3821 left to emerge. Similarly for the other years. Okay, so left to emerge. So this table kind of summarises what I've been talking about. So we started off by having information on the premiums corresponding to each of the accident years. I multiplied my premiums by this historical loss ratio, which I just said is 86%. That gave me an initial stab at the ultimate claims, the total loss that you might expect for each of the origin years. Okay? From the development factors used in the simple chain ladder method, and that is totally independent of this calculation here. Okay, using the development factors, I calculate the overall projection ratio. I invert that to tell me how much, what proportion of claims have already emerged across the development years. That immediately tells me, if I subtract it from 1, that tells me the proportion that is left to emerge. So the example that we focused on was this bottom row, where we saw that you've still got a lot of the payments still left to emerge. Okay, we've only had payments for 2012, in 2012, that correspond to accidents that happened in 2012. They're still going to develop over 2013 and 14 and 15 and 16. So we've still got, based on the development ratios, we've still got about 69% of the claims claims to emerge. Okay? Whereas, if you go back a few years, if you take the accidents that happened in 2009, yes, we paid some of that stuff off in 2009, we also paid some stuff off in 2010, and so on. And we have very little left to emerge. Okay, if I just go back to this table here, most of it has emerged. We've only got one more year left, in which we've got a bit more payment to make. All right? So the calculations suggest, from the development factors suggest, we've only got about 3% left to emerge. All right? So we're applying these factors here, proportions left to emerge, to our initial estimates of the ultimate claims that came from the historical loss multiplied by the premiums. So this column here, multiplied by the ultimate claims column, gives you the final numbers, which are the amounts, or estimated amounts, left to emerge, corresponding to accidents that happened in the different years. Okay, so if you sum those four red numbers, then you get the total amount, predicted amount, to emerge. Right. So basically, well, as I said at the start of this, you will get a different estimates, different reserves estimated compared to the basic chain ladder method that we looked at originally. It turns out that this particular Bornquetter-Ferguson estimate will come out just to be a weighted average of the initial basic chain ladder method and this estimate, which is based on the historical loss and the premium. Now you can show that mathematically, and I'll leave that for you to have a little think about. If anyone has the book by Boland, they kind of show that in more general terms. I'll just show you that kind of weighted average here. So our Bornquetter-Ferguson estimate comes out to be this kind of weighted estimate of our original chain ladder estimate, which was 3291, and the historical loss ratio, which was 3269. And the weights are governed by this thing W, and W was this proportion 1 over F. So W is the proportion of the claims that have already developed. So what happens is that if W is small, close to 0, not much has developed, i.e. we're talking about very recent years, lots of years still to develop, then the estimate will tend to this one here, the historical loss ratio. Right? You don't have very much current information. So you base your estimate more on the historical loss ratio estimate. For years further back in the past, you've got much more information about how the claims are developing into the future, and so your Bornquetter-Ferguson estimate, that should be an F, by the way, will tend more to the original chain ladder estimate. W will be closer to 1, and your BF estimate will be closer to the original chain ladder. Okay, I'll finish there, and just by saying that these are kind of fairly basic ideas that we've looked at. Of course, in practice, you wouldn't just use one idea, you'd probably use a multitude of different ideas, plus the experts' experience, the insurers' experience as well. Okay, finish there. Peter will be back with you on Friday and start talking about room.